Good morning, everyone. We'll just wait for another 5 more minutes, okay? And we'll start the session. Good morning, everyone. So, in the next 20 minutes, what we'll do is we'll just have a small quiz, okay? In the next 5 minutes, I'll just conduct a quiz. I'll share my screen. Just revise the topics until now what we have discussed, okay? We'll have a small quiz. Please join in the quiz, guys.
Hello guys. So we are going to have a quiz in few minutes. Just scan this QR and join the quiz. Guys, the code is 440764. Guys, quickly join the quiz. Going to start in few minutes. Guys, click on join a game and enter the code that you have, can see on screen 440764, and you'll be directly joined into the quiz.
So I hope everyone joined. Thank you, Frankie. So I hope everyone joined. I'll just start the quiz now. Just give me a minute. I'll just start it now. So you guys click on the link, sign up, and again click on the link and enter the code. Okay, you'll be able to join in the quiz. This is for everyone who are asking like how to join the quiz. First, click on the link. It will be taking you to the sign up page. Please sign up and sign in. And then again click on the link. It will be asking for the code. Enter the code. Okay. Then Dhruv, just simply scan the QR, right? It will be working. For others, it is working, right? How they are doing. So if it is same for others, we could have considered another way. But only for you, right? Okay, see, many of you are done. Yeah, we can't reattempt the quiz, Dheeraj. I can end the quiz, right? I hope everyone is done. And this is just a practice quiz, guys. This is just a practice quiz. Okay. I'll just wait for another 1 to 2 minutes, okay? Because we need to complete Transformers architecture. It will just take another 15 minutes. Okay. And after that, we'll do the text to text implementation. Okay. Guess what? So this is just a practice quiz. No, this won't be included in the evaluation. Okay. Don't worry. Dhruv, were you able to join the quiz or else was it same for you? Okay, I'm in the quiz now. Do you want me to show the leaderboard? Is it required? I think no. Why not? Okay. Fine, fine. I'll just show that, okay? Just a minute. Okay, something is happening here. Let me just reload this. Okay, yeah, fine. Okay, done. Done, right? Okay, fine. Okay, Vaibhav by Convex. Okay. Okay, things apart, guys. So that was just a basic quiz, okay? Basic quiz. Okay, 1 year package. Fine. Okay, fine. So getting back into the topic, okay? We'll just get back to the topic. So what are we discussing in our previous session, guys? What are we discussing in our previous session? Okay, let's get back to our session, okay? Everyone, Aditya, Anirudh, let's get back to the session. We'll discuss about the package at the end of the session, okay? Fine. So in our last session, what are we discussing? Yeah, transformers. Thank you. Hopefully you remember the concept. Thank you. So in the transformers, what are we discussing? What did we discuss in the transformers? Yeah, I'll just give a quick review also. Don't worry, Bhomik. I'm having a pre-written notes for that. I'll just share the notes and I'll just walk you through. Okay. We were writing in the notepad, right? I'll just share that notepad. I'll share the screen of it now. Just give me a minute. It's fine. Yeah, self-attention mechanism. Okay. So you guys remember it. Just a minute. Yes, Bhomik, there's a Telegram group. There is a Telegram group. Okay, now I hope everyone are able to see the screen, right? Okay, fine. Okay, let's get back into this topic. Swasti, Aditya, Sakshi, Bhomik. Okay. So what's the input sequence? So let's say this is our input text, right? Input text, which is coming into the transformers architecture. So that is an input sequence. So let's say this is our input sequence. Okay. I hope my voice is audible and clear. And after going into the input sequence, this input sequence should first go through the embeddings. Okay. What is this embeddings? Embedding that particular text. Okay. Inside this embeddings also we are having token embeddings and linear transformation, scaling, and weighted sum of values. Okay. Weighted sum of values. So in our previous session, we have discussed until linear transformation. We'll just walk through these two topics. Okay. So in the token embeddings, we have token IDs. Okay. We have token IDs. What does token IDs do? So let's say this is an input sequence. So initially this particular text will be divided into tokens. Okay. Tokens. So how many tokens we are having? 3 tokens. Correct. So for each token, the token ID is assigned. Okay. For each token, there will be token ID. So how it will be for that, it can be 101. For cat, it will be 201. It could be any ID. Okay. But a particular ID will be assigned to each token. Okay. And each token will also have 512 dimensions. Okay. 512 dimensions. So what does each dimension represent, guys? What does each dimension represent? Yes, correct. Different features they will be representing. So the size of that particular single this vector will be 512 dimensions. Okay. What does 512 dimensions means? 512 features, or else they also capture the information about the meaning, the particular token meaning, particular whole context, and the relationship between relationship with the other tokens. Okay. It will be capturing different relationships, and for this we have also considered an example describing a person. Remember, we have considered an example. So if you're considering 3 to 5 dimensions, if you want to describe a person, in those 5-dimensional space only we can represent the particular person. If you're considering these 512 dimensions, what exactly happens is we can describe a particular person with different adjectives also. Correct. So by default, the transformers architecture was built with the 512 dimensions, okay? Was built with 512 dimensions. And later we are having this linear transformation. In the linear transformation, what we'll do is we'll create the Q, K, and V. What is this Q, K, and V? Q is a query vector, K is a key vector, V is a value, Q, K, and V will be created. And how they are created? So we'll be having each token, right? For each token, a token ID will be assigned, right? For that each token, the weights will be calculated. What weights will be calculated? This query, key, and value weights will be calculated. And how we are calculating? We are computing the self-attention. I mean, that process is known as the self-attention weights, okay? So for each token X, the WQ will be, the weight of query will be added and we'll get the value for query. Similarly for K and V also we'll be getting the values. So what is happening here? They were being multiplied with the token embedding. So this is the token embedding. And here we are applying the weight over here, okay? If you see over here, WK, WQ and V are learned weights, okay? We will be calling them as learned weights because initially random weights will be assigned and it goes through the training process. And if the weights needs to be adjusted, then again the back propagation happens, the weights will be adjusted again, and then we'll be getting the perfect Q, K, and V. Okay. So up to here clear? Up to here everyone clear? Or any doubts, anyone? Okay, got it. Okay, then I see that you people are asking for these recording sessions. I'll just inform the operations team, okay? I'll just inform my team, but I'll make sure that the recording sessions are being uploaded, okay? Please don't worry about that. And those recording links you can find either in the dashboard credentials, if you're having the skill valid credentials, or else in the Telegram group only you'll be getting a recording links, okay? You'll find it over there. I hope it's clear, girl. Is it clear? Okay, then. Okay, fine. So then comes the scaling, okay? In this QK, after this linear transformation, then comes the scaling and the weighted sum values. What is the scaling and weighted sum values? The scaling is nothing but here we will be computing this each dot product, okay? Computing the scale dot product. Whatever the values which we are getting from here will be passed into the scaling. And there are two ways. We can either perform the scaling or else it's totally fine if you're not performing the scaling also. Okay? So after doing this, after going through the scaling part, then it will be passing into through the weighted sum of values. What exactly this weighted values does is it will make sure it is getting the contextual vector values. Okay, whatever the vectors which we are having, it is able to understand the context behind those vector values. It will just make sure that it is happening in this weighted sum of values. Okay. And after going through the weighted sum of values, let me just show you this architecture also, so that one more time you will be remembering this. Yeah, I'll just explain that. Okay, contextual values. I'll just explain that. Just a minute. I'm sharing my whole screen now. Just a minute. Look, advantage of scaling and also contextual vector values. I'll explain. Okay. Fine. So now the screen is being shared. Okay. So input sequence embeddings. In the embeddings, we have linear transformation, scaling, weighted sum of values, and it goes into the positional encoding. In this positional encoding also, we have types of positional encodings. We have types of positional encodings. So what are the different types of positional encoding? I'll just come to the scaling and weighted sum of values. Okay. No. So what are the different types of positional encodings we are having? Sensorial positional encoding and also learned positional encoding. So what is the main difference in between these two positional encodings? They will be assigning the position for these vectors. Okay. Whatever the vectors we are getting from these embeddings. Okay. Whatever the vector outputs we are getting from the embeddings, they will be assigning the positions. They will be assigning the positions. So how it happens in sensorial positional encoding? Based on the sine and the cosine. Okay. Based on the sine and the cosine functions, it will be creating a positional encoding. Okay. Sine and the cosine function, it will create a positional encoding in this sensorial positional encoding. And in this learned positional encoding, as per the token order, as per that particular vector order, it will be assigning the positions. Okay. If you see as per the order of the sequence, it will assign the positional positions. So as of now, we have seen this embedding input sequence, embedding, positional encoding. Then comes the multi-head attention. Okay. What exactly is multi-head attention? What did you guys understand by multi-head attention? See, there is an example over here also. We'll just see this. Multi-head attention. Multi-head attention is mainly used to capture the diverse patterns. Okay, it is mainly used to capture the diverse patterns. And in this heads also, we are having different type of hits. Okay, like we're having 16, 12, and also 8. Okay, so let's consider there is a sentence. Okay, the cat sat on the mat. Okay, or else you can consider any sentence. That is a basic example which I'll be picking up. So what exactly these heads does is, even the to build the transformers architecture, they have considered 8 heads. Okay, they have considered 8 heads. So now what happens is each head will focus on the particular sentence. So what does each head will be focusing on? One head will be focusing on the action. The other head will be focusing on the subject. The So two heads were done, right? So now the third head will be focusing on the relationships, and the fourth head will be focusing on the subject verb if it is following that vocabulary. Remember the layers. So each and every head, like 8 heads, will be focusing on each and every aspect. Okay. Now we'll just see that. So transformers is based out of 8 heads, and each head will learn to focus on different types of the relationships in the sentence. Okay. We'll focus on. Sorry. Yeah, they will focus on different type of the. Even you can consider a different example also. If you're having any example, we can consider it over here. So head one focuses on the action. So what is the action over here? Action is sat, right? And head 2 will be focusing on the, as per this, it will focus on the location. So what's the location here? Mat. Okay. And head 3 focuses on the subject. And head 4 may focus on the relationships. Head 5, it can focus on the like the subject verb object format or any layers from the NLP. Okay. So like that we're having 8 heads in the multi-head attention. So each head will focusing on one of the aspects. Is it clear until now? Not clearly audible. The thing which I have explained, was it clear or else is there any disturbance? I hope it's clear now. Is it clear now? Better? No, no. There is no limit the number of the heads, but the heads can be considered. If you're considering more heads, what exactly happens over here? It's just like dimensions only. See, if you're considering heavy dimensions for a smaller data set or else for a small amount of data, what happens? It will be learning many more relationships, many more features it will be learning. What happens? Overfitting may happen. Computational thing will be the main issue. So in order to overcome those kind of issues, there were some fixed default things like the 512 dimensions, transformers 8 heads were used. Okay, understood? Is that clear, Sanjit? Okay, how are positional encoding working and also understand? Yeah, I told right. I'll just come to that contextual vector values. Just give me a minute. So did you understand this multi-head attention? Okay, fine. No doubts, right, until now, except those two. Okay, fine. Okay, let me just share the screen again. Show my whole screen. So if you look at the architecture, we are done with this multi-head attention. So we're having this adding a normalization, multi-layer perceptrons. And again, there is this normalization. And from the encoder, it goes into the decoder. And again, the same layers are present over here. Then we got this softmax activation function for the outputs. Fine. So there is this target sequence also. Target sequence is nothing but what kind of transformers architecture that you're trying to build. Okay? So what kind of transformers architecture that you're trying to build? So are you trying to build a language translation? Are you trying to build a sentiment analysis kind of a transformers architecture? So that will be the target sequence. Okay. That will be the target sequence. Fine. So coming into this normalization, first we'll discuss about this normalization. What exactly normalization is nothing but people all know when the mean is 0 and standard deviation is 1, what we'll be calling it? When the mean is 0 and the standard deviation is 1, what do we call it as? Okay, try to answer that. So normalization, we are doing this normalization, right? So whatever the vectors which are coming out from the multi-head attention from each head, okay? From each head, we will be having that normalization, right? So here we have in this normalization, we have two different kinds of normalization, layer normalization and the batch normalization. Okay, two different kinds of normalization we can do. So what exactly we are doing here is we can either follow any one of the normalization. If you're following this layer normalization, okay, what happens is we'll be executing the things in the format of a layer, okay. In a row format, we'll be executing the things. In the row format, we'll be executing things. And if you're considering this batch normalization, column wise, let me just show you over here. So let's say like we're having the outputs, right? We'll be having the outputs. Normalization, we are having two types, layer and batch, right? Layer and batch, right? So here we'll be having the outputs from the head. All the 8 heads outputs will be having. So layer wise means it will consider row wise. Batch wise means it will consider column wise, okay? One single batch. In that case. Okay, so this is about the normalization. And then it goes into this multi-layer perceptrons. Remember the perceptrons? Single layer perceptron. Inputs, activation function, output. This is a single layer perceptron, right? Multi-layer perceptrons means for all the input there will be multi-perceptrons. Okay, fine. And then again, if normalization is again needed, if you want to make sure that all those values mean it's 0 and the deviation is 1, we can just make sure we can add another layer of normalization over here. Can add another layer of normalization over here, and from here, let me just show. So from here, it will be going into the decoder, and again from the decoder, the target sequence I just told you, right? What kind of output that you're expecting. For the target sequence also this process happens, and that will be into this multi-head attention. And from this multi-head attention, we will be getting an output, okay? Again, all the same layers you can see over here. All the layers are the same. We'll be getting an output through that, okay? Fine. So this is how the transformers architecture work, okay? This is how the transformers architecture work. And also coming into one query, which was the contextual values, right? The question was, see, whatever the output we are getting in the embedding, that we'll be considering it as a contextual vector values, okay? They will be capturing the meaning of the tokens, okay? Meaning of the tokens. Meaning of the tokens. How they will capture the meaning of the tokens? By adding those weights, okay? By adding the weights. I hope it's clear, right, Bhaumik? Okay, fine. And also, you're talking about positional encoding, right? See, positional encoding is nothing but to preserve the order of the input sequence. Okay, let's say the cat sat on the mat. See, I'm just sending that all the tokens I'm having at the from this. Let's say what was that step? Token ID, right? After token ID, linear transformation, correct? So after linear transformation, the scaling, and then comes the contextual values. Okay, contextual values will be storing that particular meaning after the weighted calculations. Correct. So after that, it goes into the positional encoding. See, if you're sending all the things will be going at once in the positional encoding. Okay. So now exactly how it will be understanding the word orders. So in order to understand the word order, it will be encoding the particular input, how it will be giving a position to that. Okay, let's say it can give a position like 101, 102, 103, 104, 105, 106. So in an order, okay, in an order, it gives the model a sense of word order. Okay, positional encoding will give us sense of word order, because In this, we are not having the recurrent or the convolution neural networks because they won't understand the order of the tokens in the sequence, right? If we're having those recurrent or else is convolutional, sorry, if you're using this RNN kind of architecture, then we can say that there is an order of token sequence which it is considering. But here, we're directly using the neural network side. So that is how it exactly works. Okay. So positional encoding and the contextual values is clear. Those are the two doubts I see. Is it clear, Bhaumik and others? Any more doubts? Okay, what about where it's complete the lab? What lab are you referring to, Vishal? So basically, so how every word is placed on this. Yeah, it will be assigning the position to each and every word or the vector. Okay. You will be receiving those credits. Okay, I'll just inform the team to check once, Gaurav. Okay, fine. So what is this masked multi-hit attention? See, uh, okay, good one. Okay, so you understood multi-head attention, right? You understood multi-head attention, right, Sargam? I'm sorry if I'm pronouncing your name wrong. I'll just address you as Tyagi, okay? Yeah. So, similarly, in a multi-head attention, what we are doing, we are giving attention, we are making sure we are understanding the each and every head is getting some meaningful context or the relationships, subject verb object format from that whole sentence, right? So what does in this multi-head attention in this masked what happens is it will selectively focus on certain parts of the input sequence. Okay, it will selectively focus on certain parts and it will be ignoring the others. How in a LSTM there is a forget gate which will be remembering the which will be pushing out the words which needs to be carry forwarded and it will be forgetting the other words, right, by using the memory state. Okay, in a similar way this masked multi-head attention also what happens is it will just ignore the other tokens and it will just make sure that it is focusing on certain part of the input sequence. Okay, and this masked multi-head attention where it will be much helpful means it will be very useful for tasks like language modeling. Okay, language modeling which will help us to also improve this performance. Okay, I hope it's clear. Okay, fine, thank you. So everyone is having the laptops with you, right? Everyone is having your laptops. Okay. So I just created a small poll. Let me know. And in the meantime, what we'll be doing is we'll just have a small break, and after the break, we'll do the text to text implementation. Okay, we'll do text to text implementation. So everyone, what you'll be doing is just create a folder on your desktop, and we'll do the text to text implementation. Okay. Okay, fine. So just attempt the poll. take a 10 minutes of short break, and we'll do the text-to-text implementation. Thank you. And also, if anyone is still having any doubt on this transformers architecture, please post it out in the chat, okay? Okay, I hope everyone is back from the break. I see many people are discussing about this credits, and also this is your second class. You're just getting the link to join. See, lab credits, regarding the lab credits, you'll be getting the information, okay? Don't worry regarding the lab credits. I'll just inform the team today, okay? By your next session, you'll be getting the lab credits. Don't worry. And every information you'll be getting an update through the Telegram only, okay? Don't worry about that, Jyoti. And also, I see many others. So you have missed a few sessions apart of completing the labs. What else we need to do? Okay, you have missed a few sessions. So Abhiram, please just Abhiram, Arushi, and also other Abhay. So please just make sure that you're attending the sessions regularly, okay? Whatever the sessions you have missed is fine for now. But please make sure from today you're attending the sessions, okay? See, that is what I'm just addressing, right, Abhiram? We'll be informing you, okay? What are all the other things which you need to perform? We'll be informing. During the session time only, we'll be informing, okay? For now, the labs is fine, okay? Okay, so everyone, so please create an empty folder, okay? Please create an empty folder on your desktop. And let me know once it's done. Let me just create a folder from my side also. I'll just name it as Generative, because we are going to implement text to text model, okay? Text to text model, which is from Google, okay? Which is from Google. We're implementing that text to text model, okay? Fine. In the meantime, let me know how many of you are aware of this Google AI Studio. Google AI Studio. Okay. Okay, fine. Done, done, done. Okay. The information will be provided to you now. Don't worry about the labs. Okay. So create a folder, and also please open Google AI Studio, everyone. I'll just share the screen. Okay. I see someone was raising their hand. May I know what's the issue? Okay. Let me just kill all these tabs away. No. Reload the tabs. Okay, just try to explore that Google Play Store. Just give me a minute, okay? Just a moment. Okay, fine. I'm just sharing my screen. I'm sharing my entire screen, okay? Okay, fine. So, one more thing. Just one second. It is already okay. Everyone are into this. Just open your new tab, open a tab, and type Google AI Studio. So you'll be seeing this. Just click on this. Okay, click on this. And for the guys who are new to this Google AI Studio, I'll just give a short intro. So this Google AI Studio is from Google, and here we can find it's a playground. Okay, it's a playground. We can chat, we can live stream, we can generate the media content, or we can build the things. Okay, and if you click on chat, you will be seeing this run settings on your right side. Run settings. You'll be having this model token count, temperature. Temperature is a parameter. Okay, what temperature does? See what it is saying. Creativity allowed in the responses. Temperature will be controlling the creativity. Okay, the temperature will be controlling the creativity. What creativity? The output sequence creativity. So let's say I have asked a query. Okay, and if my temperature is around 0.3 or 0.4, the output will be very precise to that particular query. The temperature is around 0.89 or 1, it will be completely a human kind of generated response, and also it will be creative. Okay, the model will try to think in a creative perspective or else in a creative format, and it will generate the response. You can also play with this. Okay, you can just ask a query and you can adjust the temperature and check. Okay, and there is this top p and top k parameters also. I will be discussing those parameters after this implementation. Okay, So then comes these models. Okay, what is the model that you're seeing here? Learn LM 2.0 flash experimental. Okay, the model which is used to generate the response. So we'll just see what are the other different models present. Okay, this flash experimental is only present in other. There were other this Gamma and also Gemini 2.0 and 2.5. In the 2.5 we are having 2.5 Pro preview, Flash preview, flashlight. Under 2.0 we are having 2.0 Flash preview, image generation, flashlight, and also we are having Gamma models, 4 billion, 1 billion Gamma model. Okay, we'll just see what is this. Okay, or else we'll just go with 2.0 Flash. It's good to understand. Okay, so Gemini 2.0 flashlight. Okay, and what it is saying, input output pricing, input output API pricing, all the context. So now we will be building this text to text model through API only. So that is the reason, that's the main reason actually we are exploring this Google AI Studio. So API pricing as per the 1 million tokens. Okay, as per the 1 million token inputs or the outputs which it is generating, it will be charging us. So how it will be charging? If it is hitting 1 million tokens, input will be this much, output is this much. Okay, so it's completely, we can use it for our experiment purpose in that case. And if you see what it is best for long context, real-time streaming, native tool use. What is the model? Gemini 2.0 flashlight is the model that we can use, and it is best for. What is the use case? It processes 10,000 lines of code, calls tools natively, streams the images and video in the real time. And the knowledge cutoff date. This is very important. Okay, August 2024 is the last knowledge cutoff date. Okay, and if you ask about the events which happened recently, it won't be able to answer. And coming into rate limits, this is 4000 RPM. What is RPM? Request per minute. Okay, these many requests we can make within a minute. Okay, and 30 requests per minute, or else 1500 requests per day are free. Okay, what is free? 30 requests per minute is free, or else 1500 requests per day. Okay, these are free. It's fine. So similarly, we are having other models also. 2.0 flashlight, flash preview, flash, and 2.5 Pro preview. See the knowledge cutoff. What is the knowledge cutoff for preview? Jan 2025, right? For flash preview also it is the same. Even for flashlight also it is the same. Okay, so now just so understood, right, what exactly this Google AI Studio is. Understood everyone? Okay, fine. No, we can't set the temperature to 2. Okay, the temperature will be in between 0 to 1. Okay, so Prakhar, the question is good. Okay, how exactly does a model understand the creativity? See how the model will be understanding the creativity based on the parameters. How these parameters, how are we getting these parameters? By the weights which we are applying. Okay, the learnable weights which we are seeing. Okay, based on that, this creativity will be depend. Okay, now we are getting to hear this 1 billion parameter model, 2 billion parameters. So based on these parameters only, the creativity will be dependent. Okay, creativity will be dependent on these parameters. Okay, fine. Okay, so here you are able to see this get API key, right? If you click on that, you'll be seeing this. Okay, you'll be seeing this. So let me just delete this one. This was a long back API which I have created. I will just show you how to create an API, and please make sure that whatever the API that you're creating, you you're making sure that you're not exposing your API key. Okay, If you feel like your API key is exposed, you can delete that API key and you can create a new API key. Is that clear? Fine. Just click on this create API key, okay? And just click over here. Any one of the projects will be shown up over here. I'm just going with this generative language client. So in that particular project, by default there will be a project, okay? In that particular project, an API key will be assigned for that particular project. I just need to copy that, okay? So this is my API key. I'll be deleting this API key once our session is done for today, okay? Fine. So everyone please create your own API key. Just copied it. Okay. So on June 25th, I have created it. Fine. So now what I will be doing is I'll open my VS Code. As I have created a new folder, right? I'll open the VS Code and then implement the things, okay? And also before that, there is this documentation also. Documentation. So everyone was able to see the documentation, right? So on the left side pane, you will see this text generation. Click on the text generation. So text generation, what it is saying, Gemini API can generate text output from various inputs. Various inputs in the sense text, image, video, audio. Okay. So now as we are doing text to text implementation, we'll be using this code. Okay. We'll be using this code and we'll be adding that API key and we'll be doing the implementation. Okay. So let me just open my VS code. Understood, right? This is just the documentation. Okay. Even you can go through the documentation. This is for single text input. If you want to give a multiple text input, like if you want to mention the context, like if you see over here the system instruction, okay, if you want to give, you can give that. Okay, this is some extra parameter you need to add. That's it. Okay, so clear with the AI Studio and also this documentation. Clear, everyone? Yeah, I'll just show that. Okay, I'll just show how to create an API key. Okay, everyone are on the same page, right? So what I did, whatever the previous API key I was having, I was using, I have just deleted that API key. Okay, simple. Okay, it's done. So just click on create API key. Click on this, select the project, whatever the project which I have created, or else by default there will be a specific project which has been created. Okay, just click on that project and click on create API key. Now the API key will be created. Okay, generating API key. So this is my new API key again. I'm just copying this. That's it. Clear? Clear, Baumik and also Aditya. How did we create an API key? Is it clear, Ishita? Okay, fine. I'll just share my full screen. Okay, I'll just share my full screen. Just a minute. Entire screen I'm sharing. Fine. Okay, I hope my screen is being shared. And this is an empty folder which I have created and named it as GenAI. And it is in my desktop. Okay. Now I'll just open it in the VS Code. Okay, fine. So now I have just opened it in the VS Code. So now what I will be doing, I need, what are all the things I need? I need to run my application. So I need to create a Python file, right? So I'll just create that app.py. app.py is created. And also what I need to store my API key, right? So I need an environment file also. So let me just drop the API key over here and name it as Gemini API key. Okay. So this is my Gemini API key. So the thing I need to do is I need to write the code now. Okay, I need to write the code. So I told you, right, in the documentation we'll be having the code and all. So I'll just take the documentation and this is the code. Okay, I'll just copy this code sample and I'll just come over here and I'll just paste it over here. Until here, clear? Until here, is that clear? Okay, after creating your API key, yeah, just copy that API key. You can store it in your clipboard or else you can store it in your notepad. Okay, either clipboard or notepad, anything is fine. Okay, then what you need to do is then go to your folder. Okay, go to your folder, the new folder which you have created. Open that. Okay, my screen is lagging. Please. Okay, fine. I will repeat all the steps once again. No, in the terminal. Okay, okay, got it. You're unable to follow all the steps. Okay, after copying that API key from the clipboard, what I did was I have created a folder Generative, right? In on my desktop, you have created a folder, right, everyone? So what you need to do is open that folder in the VS Code. You can directly click on this file, open folder, and open your folder, or else you can go to command prompt and you can open your folder. Understood until here? Okay, fine. So now what you need to do is you need to create a file over here. Okay, create the file. What file? So here we'll be executing the code, right? Here we'll be executing the code. So we need to create the file over here. App.py is the file. Okay, and also to store that API key, we need to store that API key, right? Because we can't directly keep that in our application. We need to store that API key. So in order to store that API key, I need to create an environment file. Okay, dot env is the file name. Okay, these two files are the main files which you need to create. Okay, should until here. Any doubts, anyone? Okay, fine. So now what you need to do is we need to write the code, right? And I told you in the documentation we'll be having the code, right? So let me just switch to the documentation. So this is the text documentation and here we are having the documentation. Okay, just copy this code, just click on this. Okay, click on this, you will be copying the code and just get back to VS Code and paste it over here. Okay, done until here. Done until here. See, if my screen is lagging, whatever the things which I'm saying, it's clear, right? Okay, fine. And even here also we need to make some changes. What kind of changes we can make? First, we need to we need to add the API key here. So let me just write Gemini underscore API underscore key. So whatever the API key that you have copied, paste it over here. So this was the API key. I have just pasted here and press Ctrl S. Okay. So save that API key. Assign a variable to that API key. Assigning the variable to that API key. Gemini API key is the variable name. So close this tab now. Okay. Close the tab. And we need to make sure that we are loading that API key, right? We need to load the API key in the file. So in order to do that, we need to import a library. Okay, we need to import that library. And library name is .env. Okay, from .env .env import load.env. Okay, import load.env. So this is the file that this is the library that you need to import. Okay, this is the library that you need to import, and also you need to make some changes also in the file. What are those changes? First, you need to load that environment variable. Want to load that, you need to type load.env. Okay, load.env you need to do. After this, we need to fetch that API key over here, right? So what we'll be doing is we will write API underscore key is equals to, okay. Now here we'll also need OS. Okay, input OS, and here, yeah, you can see OS dot get env Gemini API key, and here the API key will be replaced with the API key. Okay? Will be replaced with the API key. Clear until here? See, we got the code from the documentation, okay? And we were making changes in the documentation by loading the environment variable, by adding this library, and we'll also make further changes, okay? Because the exact same code will not work all the time. Is it clear? Anyone following me? Everyone on the same page along with me? Fine. So even here also, it's not Gen AI actually. We need to do import Google.generative AI as Gen AI. Okay? We need to do this Google.generative AI as Gen AI. And instead of assigning a client, we need to write configure over here. Configure, and this is not required. Okay, this is not required. And even here also the client and models are not required. Directly we can write Gen AI. Gen AI, okay. Directly we can write Gen AI. Models is not required over here. Actually, these things are not required, just a minute. So now we have configured this particular API key, right? In the Gen AI, from this library, we have configured that particular API key. Now what we need to do is we need to define that model. Model is Gen AI dot. It's not get model, but here we need to write generative model. Okay? Generative model, and the model is Gemini 1.5 Flash, or else any other model you can consider. So after defining the model, what we need to do, we need to write the response also. Okay? It's not generate text, it's generate content. Okay, generate content, and yeah, we can consider this France. This tokens is not required for now. Parameter is not required. So now we can do model dot generate content, and this is the prompt is also not necessary over here. Okay, fine. So this could be the response, and we need to print the response, right? We need to write print response.txt. Okay, text. So this is the 4 lines of code we need to write. Okay, These are the lines of the code that you need to write. What are we doing? .env library, loading that API key from this file, and configuring the GenAI, configuring this API key, Gemini API key. You need to make sure that the value which you're assigning over here is same as here. Okay, that is one thing you need to make sure. Configure that API key, write this generative model for GenAI, and you can use any model you want. You need to write print response dot text. Now we can run the file, but before running the file, okay, just a minute. Before running the file, there were two things that we can do. We can either create a virtual environment or we can directly proceed. Okay, we can either create a virtual environment or we can directly proceed. I'll just create a virtual environment for now. So Python, in the virtual environment, create a virtual environment with the name .venv. So it has created a folder virtual environment. Here we are having include library scripts. Under the scripts, we'll be having this activate. Okay, we'll have an activate. Once it is completely created, we'll see that activate. Okay, still creating the file. Sure. I see many things. Okay, family actions, finish not visible. Okay. I'm sorry. See, that's my fault. I'm sorry. See, Baumik, you have given your API key also. Okay. I see that you're helping, but you have given your API key over here. Please make sure you're deleting that API key. Okay, okay, I'm sorry for that. So, what are all the changes I have done? I have configured that GenAI with the API key. Okay. I have loaded the dot environment variable. And instead of using all that, I have just created this model, GenAI generative model, and response, generate the content. Okay. And from this model, I want to generate the content. And I'm storing the response in this variable. And I'm doing response.text to print that particular output. And this is the library which you need to do. Google.generative AI as GenAI. Okay. So these are all the changes which I did. Okay. Hope you are following. In my .env file, these are all the things which are present. Okay. My API key with the variable Gemini API key. You need to make sure that this variable is being called over here. The same name should be over here. If there is, if this is in lowercase letter and if this is in uppercase letter, just make sure you are either converting lowercase to uppercase or else uppercase to lowercase. Okay. You need to maintain only one case over there. If it is uppercase here, just make sure you're having uppercase over here. Okay. Clear? And in order to run this, I need to install the libraries, right? And also I have created a virtual environment. I'll just activate that. I hope everyone knows what is this virtual environment. I have activated the virtual environment and now I need to install the libraries. What are the libraries? .env and also generative AI, right? So let me just do that. Let me install python hyphen dot env and also google underscore generative AI. So these are the two libraries which you need to do pip install. Okay. These are the two main libraries which you need to do the pip install. I have shown my env file and also Yeah, I will share the code once I will show the output. Okay. Once I show the output, I will share the code and also I will share that folder also. Okay. Don't worry. Okay, fine. So these are the two libraries which you need to type in your terminal. Let me just run this. Okay, it is installing all the required library. Okay, so it has installed all the required things, packages. So it's still working on something. Just wait. Once it is done, we'll see the path. So that's how we can confirm. Okay. So until here, clear. I'll share the code also. Don't worry. Until here, it's clear. Whatever the things I'm doing. Okay. Thank you. Okay. Everything was installed. Let me just run. What is the command to run? Python app.py. What happened? Okay. See, what was the query that I was asking over here? What is the capital of France? So what's the capital of France? Paris. Correct. If you want, you can ask like what is the capital of India or else any other country. Okay. It will be giving the output over here. Clear, guys? I'll kill this terminal. But also, yeah, is it clear? I'll just write it here, Sudhay. I'll just write it in the requirements.txt file, or else I'll show you in the quick list. Okay, wait. Just show the terminal. Okay, CMD. Okay, fine. I need to activate that first. Okay, here, pip show. Okay. So this is one library, okay? Python.env is one library. And what is this version? Let's create this requirements.txt. So it's one only. So again, I need to write. I have installed Google Generative AI, right? I'll just check what is that also. Google underscore generative AI. Okay. So it is 0.8.5 version. Fine. So okay. So these two are the libraries. Okay. These two are the libraries which are required. And what you need to type is you need to type this command. See here. Pip install python fn.env space then followed by Google underscore generative AI. Okay. So this is the command which you need to type. Okay. Even hyphen or underscore both will be working the same. Okay. Either it is hyphen or underscore both will be working the same. These two are the libraries which you need to install. Clear? Everyone got the output? So what I will be doing is, did I share a drive link with you? Did I share the drive link with you guys? I'll just stop the screen. Now let me know. I didn't share any drive link. Okay. So I'll just share a drive link with you. In the drive link, I'll just upload this file. Okay. I'll upload the file. I'll upload this work file. Okay. I just create the folder. Okay, I have created that folder. Okay, the notepad notes also you want. I will share that. Okay. See, instead of the notepad notes, what we'll be doing is, I told you, right, the documentation format, the handouts. Those things will be shared with you. Okay. The handout will be shared with you in the format of a documentation. That will be helpful for you. Okay. And those links, everything will be uploaded in this drive link. Okay. In this drive link, for now, it is empty folder. Okay. Now, if you click on this link, you will be able to see notebooks and that folder will be empty. Once the session is done, I'll just upload that notebook. Okay. I will upload all those .env file, everything I will be uploading. You just need to, what you need to do, you just need to keep your API key, install those libraries and run the file. Okay. Clear everyone? Any doubts? I see 7 no's on understanding the transformers. If you're having any doubts, you can post it over here. If not, we're done for today. Okay. Yeah, I will be providing that in the drive link. Okay, girl. I will provide the whole thing, the .ami file, the app.py code, everything in the drive link. Okay. Fine. Yeah, thank you. Yeah, thank you. Thank you. Thank you, guys. Thank you. And also one more thing. And from next session, Arvind will be taking your sessions. Okay. From the next session, Arvind will be handling your sessions. Thank you. Thank you. Okay. Okay. Fine. Thank you, Verma. Okay. I hope no one is having any doubts. Yeah, definitely, Siddharth. Definitely, yes. Okay, fine. Yeah, you may leave the session. I'll just end the session. Okay. Thank you. Yeah. Have a good Wednesday. Thank you once. Have a great day ahead, you people also. Okay, today is your leg day. Chest day is done. Okay.